Very good morning. Now, today we are going to solve the examples of moment of inertia. But before starting the example, we have to use that tables which we have discussed in previous lecture. In that case, we have to memorize all the moment of inertia. That means we have two moment of inertia which Ixx and Iyy. Ixx for the rectangular section, that is BD cube by 12, and Iyy, that is dB cube by 12. Same way we have number of moment of inertia for the different shape of the laminas. Now, we have studied in a previous lecture, that is parallel axis theorem, and the equation of that parallel axis theorem, that is Ig plus AH square. Now, we have to use frequently that equation. So, let us start. Calculate Ixx and Iyy for a T section with a flange and web, each of size 60 mm by 20 mm. So, it is 60 and it is 20, again it is 60 and it is 20, which is make a T section. So, first of all, we have to finding out the CG of this section, because whenever we are going to finding out moment of inertia, that is Ixx, this xx means the axis of its CG. Iyy means again its axis of CG. So, first of all we have to locate its axis of CG. After that we are going to finding out the moment of inertia from this axis. So, Ixx and Iyy we can calculate for the two part, first and second. So, Ixx is equal to Ixx1 plus Ixx2. Same way Iyy is equal to Iyy1 plus Iyy2. So, we have to finding out first CG, and from this CG we can calculate moment of inertia of first part and moment of inertia of second part with reference to this centroidal axis. So, the section is symmetrical about y axis, that is why x bar is equal to 60 by 2, that is 30 mm. Part 1, so A1 is equal to 60 by 20 and y1 is equal to 60 plus 10, that we know. Part 2, A2 is equal to again 1200 and y2 is equal to 30 mm. We have studied in previous chapter how to finding out the CG, so that we have to that we can finding out easily, because that we have studied. Now Ixx1, the equation for Ig plus AH square, because here our CG is xx and we are going to finding out the xx1 for the part 1. So, the CG of part 1 and the original CG are parallel to each other, but at some distance. So, here always we are going to use Ig plus AH square, and Ig for the rectangular section, that is BD cube by 12 plus area into h is equal to y1 minus y bar. So we will get ixx1, ixx2 again ig plus ah square, bd cube by 12 plus area into y2 minus y bar. So we will get ixx2. Now ixx is equal to ixx1 plus ixx2. Now total ixx we can get 13.6 into 10 raised to 5 mm raised to 4. Now Iyy1. So Ig plus Ah square. So dB cube by 12 plus 12 A2. Here x1 minus x bar, but x1 and x bar both are 30, so h is equal to 0. Iy2 again Ig plus Ah square. Here also h is 0. So total Iyy is equal to 4 into 10 raised to 5 mm raised to 4. Another example. Find Ixx and Iyy for the symmetrical I section with flanges 100 mm wide and 10 mm thick, web 280 mm deep and 10 mm thick. So here it is a symmetrical, so x bar and y bar we can calculate directly. So x bar and y bar we can calculate directly. Now Ixx1, that is Ig plus Ah square. So Ig is equal to bd cube by 12 plus 1000 into, here y1 minus y bar. Here it is y1 minus y bar. So it is 145. Now Ixx2, Ig plus Ah square, bd cube by 12 plus area into y2 minus y bar, but both are same, that's why it is 0. Ixx3, Ig plus Ah square, bd cube by 12 in plus 1000 into 145 square, y3 minus y bar. So total Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. That's why it is 60.35 into 10 raised to 6 mm raised to 4. Now Iyy1, that is Ig plus Ah square. Here it is dB cube by 12 plus 1000 into x1 minus x bar, so it is 0. Again Iyy2 Ig plus Ah square. Here h is equal to 0, x2 minus x bar. Here again dB cube by 12. Here h0, x3 minus x bar. So we can get Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. So summation of these three, that is 16.893 into 10 raised to 5 mm raised to 4. Now calculate Ixx and Iyy for an unequal angle section 120 mm by 75 mm and 10 mm thick. So it is 125, it is 75, and the thickness are 10 mm. So this is not symmetrical, means it's an unsymmetrical section. So we have to first finding out x bar and y bar. After getting x bar and y bar, we have to finding out the Ixx and Iyy. So part 1 given, that is 115 into 10, that is 1150 mm square. X1, that is 5 mm, and Y1 10 plus 115 by 2, so 67.5 mm. Part 2, A2 is equal to 75 by 12, 750 mm square. X2 75 by 2, 37.5 mm. Y2 it's a 5 mm. Now x bar and y bar, that we can calculate a1 x1 plus a2 x2 upon a1 plus a2. So it is 17.82, and a1 y1 plus a2 y2 upon a1 plus a2, that is y bar, So it is 42.82. Now we have all the data. So Ixx1, that is Ig plus AH square. So it is BD cube by 12 plus area plus y1 minus y bar whole square. So we will get Ixx1. Now Ixx2, that is Ig plus AH square, again BD cube by 12 plus 750 by 42.82, that is y2 minus y bar. So total Ixx that we can calculate from Ixx1 plus Ixx2, and that is 3.04 into 10 raised to 6 mm raised to 4. Now Iyy1, that is Ig plus AH square. So Ig is equal to, here Ig, that is dB cube by 12 plus area into x1 minus x bar whole square. Iyy2, again Ig plus AH square dB cube by 12 into area into x2 minus x bar whole square. So we can calculate Iyy, that is Iyy1 plus Iyy2. So Iyy is equal to 8.4 into 10 raised to 5 mm raised to 4. Now this is most important question. Here we have to finding out moment of inertia of the shaded area about AB axis. So here AB axis that already given. So we not need to finding out the x bar and y bar, because here not calculate the Ixx. Here we are going to calculate IAB. So whenever we have to finding out Ixx and Iyy, that at that time we must have to finding out the axis of CG. But here they have already given that you have to finding out moments of inertia from AB axis. Then axis already we have. So no need to finding out the CG. But we have to finding out moment of inertia from this axis. So here we have three part. First part is right angle triangle. Second part is half circle, and third part is full circle. But this full circle have to deduct it, because we have to finding out only shaded portion. Now we have all the dimensions. So moment of inertia of the triangle about its base. So we have equation of triangle base, that is BH cube by 12. So we will get the 3.41 into 10 raised to 6 mm raised to 4. Now for the semicircle, so equation for the semicircle at base, that is pi by 128 80 raised to 4. And moment of inertia of the circle at the center, that is pi by 64 d raised to 4. So the total moment of inertia IAB is equal to IAB1 plus IAB2 minus IAB3. So it is IAB is equal to 4.295 into 10 raised to 6 mm raised to 4. Now this is type of C section. Determine the location of the centroid and moment of inertia of the given lamina about x axis. So here we have to calculate only x axis. No need to finding out Iyy, because they have given only about the x axis. So for the finding out x axis, we have to finding out y bar. Clear? Just refer this figure what they have given. This is 80 mm, this is 15 mm, this is 20 mm. Here it is 120 and it is also 120 mm. Now, The given section is not symmetrical about any axis. So we have to finding out x bar and y bar. Now part 1, a1 is equal to 80 by 15, x1 is equal to 40 and y1 is equal to 20 plus 120 plus 7.5. Same way part 2, a2 120 by 20, x2 10 and y2 20 plus 120 by 2. Same way part 3, a3 120 by 20, x3 60 and 10. Now we can calculate that x bar a1 x1 plus a2 x2 plus a3 x3 upon a1 plus a2 plus a3. So we will get x bar, that is 36 mm, and y bar is equal to a1 y1 plus a2 y2 plus a3 y3 upon a1 plus a2 plus a3. So it is 65.5 mm. Now moment of inertia Ixx is equal to Ixx1. Ixx1 is equal to Ig plus Ah square. Ig is equal to Bd cube by 12 plus area into y1 minus y bar. Here it is y2 minus y bar. So for Ixx1 y1 minus y bar, Ixx2 y2 minus y bar, Ixx3 y3 minus y bar, that we can take. If it is Iyy, then here it is x1 minus x bar, like that. So here Ixx1, that is 8.09 into 10 raised to 6 mm raised to 4. Now Ixx2, that is Ig plus ah square 1 again. So here it is Bd cube by 12 plus area into y2 minus y bar. Same way Ixx3, Ig plus ah square, again Bd cube by 12 plus area into y3 minus y bar whole square. So total Ixx is equal to Ixx1 plus Ixx2 plus Ixx3, that is 18.94 into 10 raised to 6 mm raised to 4. This is another most important question. Calculate the moment of inertia about x-axis of the plane area shown in the figure. So here it is first part, that is rectangular, second part is half circle, right angle triangle, and this is quarter circle. So we have all the dimension of this. So for the finding out x-axis, we need to finding out y bar. So Ixx1, that is Ig plus Ah square, Ixx2 Bh cube by 12 and Ixx3 pi by 16 r raised to 4. We have to memorize this equation for the half circle, quarter circle. So Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. So the summation of these three, that is 3.164 into 10 raised to 5 mm raised to 4. So here we have number of cases how to finding out the moment of inertia and from which axis we need to finding out moment of inertia, that is important. Another case, determine the moment of inertia of the plane lamina shown in the figure about its base. So from here we have to finding out the moment of inertia. So here first part, that is rectangle, second part that is right angle triangle, and third part, that is half circle. So from the base we have to finding out the equations. Now first part, that is rectangle. So here I base for the first part, that is Ig plus Ah square Bd cube by 12 Ig plus area plus from here to its center, that is I. So it is 150. So we can calculate 3.6 into 10 raised to 9. Now for the second part, it is a right angle triangle. So I base 2, that is BD cube by BH cube by 12, the equation we have, and the semicircle, that is pi by 128 into d raised to 4. So now for the I base, that is I base 1 plus I base 2 minus I base 3. So we will get 3.85 into 10 raised to 9. The important thing for the from where we have to finding out moment of inertia, that is important. Another case, determine the moment of inertia about the horizontal centroidal axis. So first we have to finding out the CG of this lamina, and after getting that, finding out the Ixx1, Ixx2, Ixx3 as we know. Clear? So thank you very much.